it says you want to find the arc length of a circle given a central angle in radians or degrees. So we have to talk about it in radians, which means in terms of pi, or in degrees, which means what it says in terms of degrees. So circumference of a circle, you should already know this. This is the review part, the intro. Circumference of a circle is the distance all the way around the circle, and it shows you the formula for the circumference of a circle, which is pi d or 2 pi r. Those would be the same. So either one works for the circumference of the circle. D is the diameter, r is the radius. So based upon that knowledge, you should be able to answer these first three questions. So question number 1 says the radius of the circle is 11 inches. Find the circumference of the circle and round to the nearest hundred. So we know that the circumference is 2 pi r. And in this problem, it tells us that the radius is 11. So we can go straight to our calculator and type in 2 and then pi, and then in parentheses you can type in 11. And when you do that, again, some people go and type in 3.14 instead of pi, but you can. It's not difficult to just go and hit the pi button on there. So 2, second, the little caret sign for pi, and then 11 is in parentheses. You get 69.12 is your circumference, and that would be in inches. Okay. Number 2 says the diameter of a circle is 4 meters. Find the circumference of the circle and round to the nearest hundred. Same thing. Now, in this case, you could use the same formula I used at number 1 and plug in 2, because if you know the diameter is 4, you know the radius is 2. But you can also use the other formula as well and say that's just pi d, and the diameter is 4. So when you plug in 4, we're saying 3.14 times 4, so we're going to get 12 something.
12.56.
Sounds good. So 12.566, so that's 12.57 if we're rounding to 2 decimal places. And again, this one is in meters. Okay.
When we do like assignments for you and stuff, and if we're like a few like off, you can say, because if some people use 3.4 or 5,
Yeah, it's fine.
you will take point off.
Because I have the answer is 69.05 in the first one and 12.56 in the second one. So I have both. Some people use 3.14. Number 3, the circumference of a circle is 6 meters. Find the radius of the circle and round to the nearest hundred. So in this case, you know circumference equals 2 pi r. And here, you know the radius, or you know the circumference of the circle is 6. So 6 equals 2 pi r. We want to solve for the radius. So we're just going to get the radius by itself. So we're going to divide by 2 pi. So 6 divided by 2 pi should get you the radius. The radius should equal 6 divided by 2 pi, which is going to give you 9.42. And that is meters. And again, you can write that in there. Why is that not right?
That's what I told. not what I'm getting on my calculator.
Me either.
I'm getting like
0.96.
0.954.
Yeah, that's what I got. So 6 divided by 2 pi is 6 divided by basically 6.28. Just wonder why my calculator. 6 divided by maybe.
When I put in the parentheses.
You do.
the point.
You have to put in parentheses. So when I do like this. So when I do 6, it's basically doing 6 divided by 2. So there's a good catch there. If we don't put it in parentheses, then what our calculator is doing is 6 divided by 2, which is 3, and then it's doing 3 pi. So what we want our calculator to do is 6 divided by 2 pi. So we put the 2 pi in parentheses. And so we get 0.95 meters. I knew the radius would not be bigger than the circumference. That's what
You
kind
don't
of brought my.
put the parentheses on this one.
Correct. Yep. So 6 divided by 2 pi is right there. And if you're using Desmos, you don't. It sets it up for you as a fraction, which is nice. So there's 1, 2, and 3. All those come from circumference and the radius and diameter. So those are things that we should have solved before. So I'm now going to erase. And we'll move down to the next set of questions. And the next set of questions here talk about the arc length. So we're now looking at kind of the big part of today's lesson. This first arc length is in radians. So it says the length is equal to r times theta. Theta is a symbol for an angle. So if you see that little circle with the line through it, that's a Greek symbol for angle. So you'll see that all throughout math. Whether you're looking for that certain angle, there you'll see theta. L is the arc length. R is the radius. And theta is the measure of the angle. So you can kind of see what we're talking about. When we talk about arc length, they are talking about this red area here. That is the arc length. This is the angle. And then your radius is the distance from the center of the circle to any point on the circle. And there's the formula for it. So in number 4, it says the radius of the circle is 1. And I know this is hard to see, but there is a 1 here. So the radius of the circle is 1. And then it says this is the angle is pi over 3. So it says what is the length of the arc. So we're just going to use our formula. L equals R times theta. And we know that the radius is 1 and the angle is pi over 3. So we say 1 times pi over 3. And if we do that in the calculator, you're going to get 1.05. So the length is 1.05. And in this case, they don't give you a unit of measurement here for this. Typically, they'll tell you, like, is it in meters or feet or something like that, like they do in number 5. In this one, they didn't tell us, so I just put units. Okay? So basically, you need the radius and the angle if you're wanting to find the arc length. Number 5, the radius of a circle is 13 meters. What is the length of an arc that uses an angle of pi over 5? So that's pi over 5 there. So again, the length equals the radius times the angle. We know the radius is 13 and the angle is pi over 5. So we're just saying 13 times pi over 5. And we get 8.17, and that is in meters. Okay, if you move to the bottom of that sheet, it's not on the board, but we'll go ahead and do it. It says the radius of a circle is 17 miles. What is the length of an arc that subtends an angle of pi radians? So again, for number 6, we're just going to say the length equals the radius times theta. The radius in this one is 17, and then this is pi. So we're really just finding what is 17 times pi. And we get, we get 53.41, and that's in miles. So 53.41 miles. That would answer number 6. And all of those show you a circle with it, so you can kind of see the circle as well as you're going through the problem. Does anybody have a question on that? Okay, that'll take us through page 1. So we'll move to page 2. Now notice in page 1, these 4, 5, and 6, we were doing the arc length in radians. So we were leaving it with pi, right? So when we plugged in the angle, we plugged it in with pi. All the way around a circle is 2 pi. That's why you see the circumference formula being 2 pi times the radius. That's all the way around the circle is 2 pi. So 2 pi is the same as 360 degrees all the way around a circle. So that means 1 pi is the same as 180 degrees. So arc length in degrees, I'm going to convert the degrees to radians and then use the radian formula. So to convert degrees to radians, you have to take the angle and multiply by pi over 180. So basically what that means is if you have an angle here in number 7, the angle is 60 degrees and the radius is 8 right there. So if I want to find the length of this, I have the angle and the radius. So the first thing I need to do is make this angle into radians. So I'm going to say 60 times pi over 180. Really what you're doing is you're taking 60 divided by 180, right? So that's 1/3. So this is basically 1/3 pi is how you're changing it. So this is just pi over 3. So 60 degrees, if you think about it, pi is 180 degrees. 2 pi is 360. So 60 pi over 180 is just pi over 3. Okay? It's 1/3 of pi. So that is our angle. So a 60-degree angle is pi over 3. So now we go to the length is equal to the angle times the radius, or the radius times the angle, either way. So the radius is 8, and then we have pi over 3. So now we can get our arc length. So it's just 8 times pi over 3. So there's one extra step there. You get 8.38. And that is centimeters. So there's one extra step. The extra step was getting the angle from degrees to radians. Now, if you look at B, it talks about the circumference here of the circle. So the first thing you would like to do is you want to take the angle. So it's 40 pi over 180. That's basically what you do. You put pi beside it and divide it by 180. That's what you're doing there. So 40, but I know that 40, if I want to keep it in fraction form, I can just put 40 over 180 in my calculator and reduce that fraction. That's 2/9. So I know this is 2 pi over 9. That's what 40 degrees is. And so in this one, it's a little bit trickier. In this one, I have the arc length. I do not know the radius. Well, to do the circumference, to find the circumference of the circle, I need to know the radius. So I'm going to use that in my formula. So the arc length is equal to the radius times the angle. I know the arc length is 4.19, and I do not know the radius, but I do know the angle. So 2 pi over 9 equals, 2 pi over 9 times the radius. And so in this case, I do not know the radius, so I need to take 4.19 divided by 2 pi over 9. And I should get 6 on my calculator. Should get R equals 6 when I do that. So I'm dividing by 2 pi over 9. So you pay 4.19 divided by parentheses 2 pi over 9. You'll get that the radius is 6. So now that you know that the radius is 6, you can find the circumference. So the circumference equals 2 pi r. Circumference equals 2 pi times 6. That's the same thing as saying 12 pi. Right? So 12 pi is 37.7. And that is in inches. Whew, that was a long one, kind of. Okay, moving forward. That was part B. These questions. Number 1, it says, what is the radius? So at number 1, what's the radius? That's 15 inches. So you got it. 15 inches. Okay. The central angle, how can you get it? The 210 is this angle. We want what this angle is because we're going from P to Q. Yeah. So 360 minus 210 equals 150 degrees. Now that's written in degrees. We want to change it to radians. So remember, if you're changing it to radians, you put pi with it. So 150 pi, and it's divided by 180. So we can just reduce that fraction. 150 over 180 is 5 over 6. So 5 pi over 6 is our central angle. Okay, so if you know the angle, just put it divided by 180 and you can reduce that fraction. And then you know that pi has to go with it. Now, the length of the arc. So at that point, you have L equals R times the angle. R is your radius, that's 15. Your angle is 5 pi over 6. So you should just be multiplying those together. So 15 times 5 pi over 6 is 39.27, and that is in inches. Does that make sense?
No.
Okay, thank you. So moving on. Number 2. All right.
Okay.
I actually think it makes a lot of sense. 360 minus 210 is 150, so that angle has to be 150. 150 divided by 180 is 5, 6, so it's 5 pi over 6. You've got your radius, you've got your angle, so you can do the arc length.
You're just plugging stuff in.
Yes. Once you have your radius, that's why they're doing it in order, because to do the length of the arc, you need the radius and you need the angle. So they're basically showing you these are the 2 pieces you need to do the last part. Yes. So the radius in number 2, the radius is 7. It's given to us, 7 meters. And the central angle is not given to us, okay? But we'll be able to get it. And then the arc length is already given to us. So the arc length is 15.87 meters. Okay? So the only thing that we don't have is that angle. All right? So what we're going to do is we're going to say 15, I'll put it up here. We'll say 15.87 equals, and we'll say 7 times our angle. That's our formula for arc length. L equals the angle times the radius. Okay? And so to do that, now we're going to divide by 7 to try to solve for our angle. So our angle equals 15.87 divided by 7. That's 2.27. That's not the answer yet. Okay, so to find our final answer, we're going to say 2.27 . 2.27 is basically your units of measurement. So it's how many times, it's basically your angle as in theta, which is rare that we don't have the angle measurement. But when we don't, we're going to multiply it by 180, because that's what pi is, and then divide it by pi. Okay, and that's going to change it back into what we want, which is the angle into degrees. So basically, we were moving it to, think about, if you look at it, if we were taking one from degree, look at the formula at the top of the page. We were trying to take it from degrees to radians, right? So we multiplied by pi over 180. Now, we're actually trying to take an angle and move it from radians into degrees. So that formula, pi over 180, it would actually be 180 over pi. So that's why you multiply it by 180 and divide it by pi. Okay? That's rare that happens, but it did here. And when you do that, it actually turns out perfectly. You get 130 degrees. So that is your central angle, 130 degrees. Doesn't happen very often, but it can.
Why is that flip?
Because we are changing it from radians to degrees instead of from degrees to radians. So in our formula, if you want to change something from degrees to radians, you multiply by pi over 180. If you want to change something from radians to degrees, you multiply by 180 over pi. Yes, it just flips that. So let's look at the last one. We don't know the radius. We do know the central angle, 50 degrees. We do know the length of the arc, 9.6, right? So the first thing we can do is take 50 degrees and figure out what is 50 degrees in radians. So how do we change it? So we're going to say 50, remember that's 50 pi over 180. So how can you reduce the fraction 50 over 180?
5 to 18. 5 over 18.
Okay, and can you reduce that? You can. Okay, so 5 pi over 18 is your central angle. It's 50 degrees, but that's 5 pi over 18. So now you know 2 of the 3, so you're good. You can solve for the radius. So let's go up here. Let's say the length equals the radius times the angle. So the length in this one is 9.6. The central angle in this one is 5 pi over 18. And we don't know the radius. So we can take 9.6 and divide by 5 pi over 18. Remember, when you divide, you got to put it in parentheses. So now the radius equals 9.6 divided by 5 pi over 18. That gives me 11. Comes out perfectly as my radius. That's 11 centimeters. Okay, quickly down to 4, 5, and 6. So I'm going to scroll down here in just a second. to 4, 5, and 6. I'm going to show you what they're asking you to do there. I think these will be easier too. So if we scroll down, 4, 5, and 6 just wanting the length of the arc. They all have the radius and the angle. The only issue is in these problems in 4, 5, and 6, the only issue is that it's not in radians. Okay, it's in degrees. So we need to take that. We already know the radius, but we need to take the angle and change it into radians. So in the first one, 160 divided by 160 pi over 180. So 160 over 180 is what as a fraction? How can you reduce that? Yep, 8 over 9. So 8 pi over 9 is our angle. And we already know our radius is 20. So we have our angle and our radius. Let's look at 5 real quick. Our angle is 40. So let's say 40 pi over 180. That would be 2 over 9. So 2 pi over 9 is our angle. And we already have our radius is 5. And this one it's 20 feet. And then over here, 85 over 180. Gives you 17 over 36. So 17 pi over 36. That's going to be your angle. And you have your radius is 14. So in all of these, you have your angle in radians. And you have your radius. So you can use the formula, the length equals the radius times the angle to get your arc length. Okay? And you want to, when you get your arc length, you want to round it to 2 decimal places on here. And that should wrap up the page. So when you get those, I'll let you go through and give me the answer there. Okay, what do you get in the first one?
55.85.
Yeah, so 55.85, and that's in feet. So we're just multiplying 8 pi over 9 times the 20. And then in the second one,
3.49 meters.
3.49 meters. And then lastly, 7/8.
7.
Sure.
No, 7, sorry.
Okay.
Yeah.
And that's in centimeters.
Yes.
Okay. So those are your arc lengths. So again, the goal today is basically if you have a radius and an angle, we're changing that angle to radians, which just means putting pi on top, dividing by 180, reducing it as much as you can, reduce the fraction as much as you can. And then you would then multiply the radius times the angle to get the arc length. And that's really the whole key for the arc length today.